Okay, well, since I was shooting some problems to repair the previous damaged video, I thought I would do a few extra questions just as a little bonus. I know that this particular topic really gives students fits, so I just made up a different example. I put 12 minus 3 radical 2 divided by radical 6. And again, when there's one thing on the bottom, it's definitely easier, but that doesn't mean that it's easy. So when there's one radical on the bottom, that is exactly what you multiply by. Remember, the goal is to remove the radical on the bottom. So on the top, I have 12 minus 3 radical 2. Now, normally I would put the radical 6 here. But you know what? There's nothing stopping you from putting it here in the front because this is where you're used to seeing it. So I'm going to just move it to the front. And on the bottom, I have radical 6 times radical 6, which is just 6. I don't know if I did this in the other video, but you could still distribute it from this side, right, and hop over the other way. But I do think that it is easier to distribute from this side. Now, you cannot reduce this, right? Radical 6 is not divisible by 6, right? You have one into jail, one out of jail, so you can't divide that. So you have no choice here but to do the distributing. Now, this is where students make the mistake. They'll just write a 12. This is 12 times radical 6. So you have to put 12 radical 6. And then over here, you have negative 3 times 1. That's why I put the 1 here, right? 1 times negative 3 is negative 3. That's outside. And then radical 6 and radical 2 make radical 12. And again, I still have on the bottom the 6, the trap. I hope you see the trap. First of all, you can divide all these by 3. And it's not wrong. You can do that. You can divide that by 3, that by 3, that by 3. The mistake, though, is that students will just divide 12 by 6. They'll cross these out and they'll put a 2 there. And they won't even bother breaking this down. I mean, this breaks down, right? You have to break that down. So I'm going to just write that step above it just to save myself 2 seconds of time, right? You break the 12 down into, so over there you would have negative 3 times radical 4, radical 3, right? This would come out of jail as 2. So that step I will write. Right, so you break the 12 down, and then you still have that 6 there. It's important. You have to recognize when you see these numbers, 12, 18, 20, 24, when these numbers are divisible by 4 or 9 or 16, you have to break them down into a simpler radical. A lot of students just miss that. They see the radical 12 and they just stop there. 12 and 18 show up all the time, right? 18 is 9 times 2, and 12 is 4 times 3. So, perfect squares, you have to break them down. So then you multiply it, right? You still have that 12 radical 6 waiting and waiting. 3 times 2 is 6, all divided by 6. Now, again, I want you to think of it as this, because this is really what it is. It's really that, right? When we learn fractions, same bottom, same bottom. Keep the bottom, add or subtract the tops. It seems like you are crossing out the 6 twice. I do get that. It seems to your brain that you just want to put the 6 into 12, but it has to go into both numbers. So 6 goes into the 12. Yes, you get 2 radical 6. And then 6 divided by 6 is 1, and the negative stays there, right? So that's what it is. You could also if you liked the factoring, let's go in the other direction. It's annoying for me to go that way. You could factor a 6 out of the top. We did factoring many times, right? GCF. These numbers, you cannot mess with the radicals. They're in jail. You never mess with the people in jail. You could factor a 6 from the top, and that gives you 2 radical 6 minus, right? Divide that by 6 minus 1 radical 3. And then you could cross out those 6s. If it makes you feel better to do that, right? That's what we did. We factored out the GCF, and you could cross it out, divide, right? Division across multiplication is okay. Some people say, but you can't divide across the minus. I can if it goes into everything. Because if I put this 6 into 12 and 6, then I'm not dividing across the subtraction. I'm dividing them both. So that's why it's allowed. Whatever you want to do, that's what you get. Now I'm going to do a much harder example, an advanced one. It's not one that I would put on a test, but if you can do the really hard one, then when you go back and do the more basic ones, they're going to seem really easy. All right, so number 10, this problem is an absolute beast. And again, I don't, this wouldn't make a good test question for obvious reason. It's quite difficult and a lot of students who get it wrong. I want to make sure you can do the fundamentals, but if you can get this one, then you can do any of them. So again, I like parentheses there. Now, I have binomial, right? Double, double. I don't even like to call it binomial, right? You have a double and a double. So same thing though. You ignore the top. You look at the bottom, and it's always the conjugate, right? So you're going to use the conjugate. All you do is switch the sign in the middle. There, that part's easy. Yes, students forget that part, and then the whole problem gets screwed up. You have to make sure you switch that sign. Now, the bottom is a little bit easier to multiply out. The top, I'm not going to multiply yet. I'm just going to write it again, and I'm going to wait a second because it's tough to do them at the same time. The bottom is easy to do, right? And I don't know if in the other video I told you the trick, but basically what you can do is you can take whatever number is inside that radical and then whatever number is inside that radical and then just subtract them. I know there's going to be a 2 on the bottom. I mean, I've done these enough times. You're not allowed to do that though. I need to see the entire product. And I have had students just tell me 5, take away 3 on the bottom, and they lose a point. Radical 5 and radical 5 is 5, right? It's radical 25. Positive radical 5 times negative, that's going to be negative. So radical 5 times radical 3 is radical 15. In the middle, I have positive radical 3 times radical 5. That's positive radical 15. And then at the end, you have a positive times a negative. This will always happen, right? The conjugate switched the middle sign. So you will always get a negative here. Always. That's another little check mark for you to see if you're doing it right. Radical 3 and radical 3 is 3. And then again, the middle's crossed out, right? That's your benchmark. If that didn't happen, then you made a mistake in your product or you didn't times by the correct thing. All right. So assuming you use the conjugate correctly. So on the bottom of that, I just get 5, take away 3, which is 2, which is what I already said. Now, the top I'm going to do over here. This is a complicated multiplication. It's definitely more complicated than the one that you did on the bottom. The one you did on the bottom is easier. Why? Because by multiplying by the conjugate, you created a difference of squares. So the inner and the outer crossed out. So all you had was what was in the front and what was at the end, right? The first and your FOIL. The first and the last. The inner and the outer crossed out. So that product is much easier than this product. This product is much more complicated. So I'm going to put the little ones there. I can't fit them. 3 times 1, 3. Radical 5 times radical 5, 5. Right? Get more sophisticated. If you want to write radical 25 there, you can. But I'm going to do this, right? We're a little more advanced now. So I did my first. Let's make the arrows. So I did the first. Now I have to do the outer, right? You're just doing your FOIL. Distribute one thing at a time. I did 3 radical 5 times radical 5. Now I have to do 3 radical 5 times negative radical 3. So I have 3 times negative 1. Radical 5 and radical 3 is radical 15. Now I do like to go underneath. I don't like to continue on over there. If you want to continue on, then continue on. It's fine. Whatever you like to do. I like to go underneath so that they're lined up together. So now I'm going to do my inner. Negative radical 3 times radical 5. Ooh, look, I got another one. So it's negative 1 times 1, right? Negative 1. But I got another radical 15. That's the whole point. You have to get another radical 15 there. Or else they don't combine. So now in the end, be careful. Negative 1 times negative 1. This looks so stupid, it's annoying me. Negative 1 times negative 1 is positive 1. Radical 3 times radical 3. Radical 9, which is 3. I'm running out of room, but it's going to fit. Over there, you get 15. Now, this is the important part, right? You got to combine all of those together, but it's not that hard. But man, does this go back to day one, right? Negative 3, negative 1. People tell me 2, negative 2. I mean, right? Signs everywhere. No matter where you are, the signs pop up. Minus 3 minus 1 is minus 4. Radical 15s. Now, I know students somehow when they think, like they see that subtraction and they think that the radical 15s cross out. But I mean, if you had minus 3 apples, minus 2 apples, right? I mean, you don't make that minus 5. Minus 5 what? Minus $5 all of a sudden, right? If you ate 3 apples and ate 2 apples, you ate 5 apples. This letter wouldn't cross out. So you can't cross out these radical 15s here just because you're doing subtraction. I do see that mistake that students make. So 3 times 1 is 3. So I had a positive 15 and a positive 3. That makes 18. All this crap was me just doing the top. That's why this problem is very advanced. And then in the middle, right, the inner and the outer, right, my rainbow, although I didn't really make a good rainbow, you have negative 4 radical 15. Oof. But you can see why this problem is difficult, right? The bottom isn't so bad to times out, right? You just get that 2. But the top, I mean, you had to go all out. Multiply this very carefully. Any sign error, any little mistake here, the whole problem, because then you mess up what's on the top of this fraction and the whole thing is shot. But now look, 18 and 4. Like I said, they're both divisible by 2. Now, again, if it makes you feel better to factor the 2 from the top, right? 18, right? 9 times 2, right? 18 divided by 2 is 9. 4 divided by 2, right? You can factor out the 2 and then cross out the 2. I don't do that. I just divide it. I'm going to go 18 divided by 2 is 9. And then 4 divided by 2. As long as you divide both numbers. And I said already, if it makes you feel better, split it up into 2. You can split it off into 2 fractions. That is what it is. That's what it means. That fraction is 18 divided by 2 and negative 4 radical 15 divided by 2. That's what it means. So that's why the 2 divides into each of them. That is that answer. Again, that's a really tough question. If you could get that one, then really you can do them all. All right, this is a good question. That's why I have a few like that. Number 12 is like that. Number 14 is like that. And I don't expect people to be able to do them all. I expect you to be able to do, certainly the first 6, maybe first 7 are fair game for what will be on the tests and the quizzes. So hopefully this was helpful. So now you get a bonus video that wasn't there before. So enjoy.